Hi, I'm Kailey Epstein. I'm a rising third-year student at MIT. I'm doing a summer internship with Kyle. I'm majoring in computer science, and so what I've been working on is NAV-SI. It's a navigation and visuospatial information app, and so I'll talk through it today. So first, the motivation. This was kind of one of Kyle's passion project ideas. Loving to travel and being really adaptable with technology has led him to explore many of these AI-based navigational aids. And typically, these visual question answering apps use live camera video feed and AI in order to respond to a user's prompts in real time so they can get information about the world around them in order to micro-navigate and just have a better sense of where they are. But there were a few shortcomings that Kyle particularly found. For example, they often have insufficient or inaccurate spatial reasoning. And this is super important for navigation because just knowing like if a car is to the left or right of another car is really helpful in order to get a mental picture of what's going on. They also typically tend to rely on cloud infrastructure, and this means you can have lag or availability issues if you have poor service or a lack of connection altogether. And this also leads to reliability issues because the developers can be changing the models behind the scenes in the cloud, and then that directly impacts you and you might not realize it. Additionally, this has privacy concerns because you have no assurance that your data is yours alone since it's being broadcast up to the cloud. So to address these issues, but also keep a lot of the really beneficial and valuable aspects of these apps, we developed NAV-SI. And right now it has two main features. The first is object detection. And so basically how this works is you'll open the mobile app on your phone. It's entirely voice controlled and on device. And so let's say you're in a park and you're looking for a bench or chair to rest at, you would just actually audibly say that prompt, I'm looking for a bench or chair to rest at, and then it would begin searching for benches or chairs around you and notify you when one was found. It also has positional and color information, so it looks at 9 different quadrants to let you know where in relation to your screen the object is, and color information in case you're looking for your red handbag or your blue handbag to bring to work. And you can also just ask to name all objects around me if you just want to get a really thorough mental picture of everything going on. Then the second feature is text detection, and this is looking at text in the wild. So say, for example, you use Google Maps to navigate to Cafe Nero, but then you're not sure where you're oriented in relation to the actual doors of the building. You could use the prompt Nero and then wait for the camera feed to pick up the store sign so you could know exactly where to walk. You can also, once you're inside, let's say you were handed a menu, ask it to read out all text so then you could have the information of the available food options just on your own. And so those are the 2 features that are currently working and that I can demo for you today. Future plans are to add a face identification feature, and this would use a saved database of that person's personal faces, people who were close to them, important to them, to identify surrounding people in the frame. We also want to interface with AirPods or wireless earbuds. So instead of having to use the phone touchscreen to start recording, we could automatically work with their microphones and touch control to just make it more accessible overall. And then finally, adding a large language model layer. This would allow us to automatically select detection tasks and settings from a wider variety of user prompts instead of doing simple string matching. So that's where the project's going, and thank you for listening.